We can also use this formula to find the unknown coordinate of a given point, as long as we know the distance between 2 points. Let's look at some examples of how we do this. The distance between points A and B is 8,4853 units. Calculate the missing coordinate of point B. From the diagram, we can see that point A has coordinates -3, 2, and B has a y coordinate of -4, but an unknown x coordinate. This is what we need to find. The distance between A and B is 8,4853 units. So let's start with this, and we can write this down over here. 8,4853. We make this equal to, and now we can fill the coordinates of our points into our formula. Let's say that A is our first point and B is our second. So now we open a bracket and we say the y coordinate of B, -4, minus the y coordinate of A, so we say -2, close the bracket, squared, plus the x coordinate of B, which is simply x, minus the x coordinates of A, -3. So we say minus -3, we get +3 squared. And we put all of this under a square root. Now, to solve for x, we first need to get rid of the square root sign. And the only way to do that is to square both sides. So we're going to square this side, and we're going to square this side. Now we can get our calculator, and we're going to say 8,4853 squared is equal to 72,0003, which we can leave as 72. We say 72 is equal to, on the right, the root and the square will cancel, and we're left with our brackets. In our first bracket, -4 minus 2 gives us -6. So we can say -6 in a bracket squared, plus, and for now, let's just leave our second bracket, x plus 3, as it is. Now we can expand our brackets. So on the left, we have 72 is equal to -6 squared, which is 36, plus, now we need to square our second bracket, x plus 3 squared, and we get x squared. X multiplied by 3 is 3x, double it, and we get 6x, plus 3 squared, which is 9. Now we have an x squared term over here. So we can see we are working with a quadratic equation. Let's quickly add like terms on the right-hand side. So on the left, we still have 72 is equal to x squared plus 6x. Then we have 36 plus 9, which gives us positive 45. We know from algebra that in order to solve for x, we need to factorize this equation. But before we can do this, we need to make the equation equal to 0. Our square term is positive, so we can leave this as it is. And we can say x squared plus 6x plus 45. Then we need to move the 72 across, so we say minus 72, and we make this equal to 0. Now, before we factorize, let's add like terms. So we have x squared plus 6x, 45 minus 72 gives us negative 27, and we can make this equal to 0. Now we can factorize this into two brackets. Our constant is negative 27, so one factor will be negative. The coefficient of x is positive 6, so the smaller factor will be negative. Negative 3 and positive 9 are factors of negative 27, and when added together, they give us positive 6. So now we can open our brackets, and we can say x minus 3, and our second bracket, x plus 9, and now we can make this equal to 0. From this, we can see that x could be positive 3, or it could be negative 9. So we can say x could be equal to 3, or x could be equal to negative 9. But B is 1 point. It can only have one x coordinate. So which one is it? From our work with the Cartesian plane, we know that x is negative to the left of the origin and positive to the right. Here, B lies to the right of the origin, so x must be positive. And this shows us that x cannot be negative 9, which means x has to be equal to 3. And this is our answer. Let's do another example.